Zombie apocalypse.
Hello everyone, welcome back to Eco Talks with Sneha Manerikar. In today's session, we'll discuss few more questions from the topic Econometrics. So let us start the session with our first question. Multicollinearity is problem related to A. Dependent variable, B. Independent variable, C. Intercept, D. Disturbance term. Answer is B. Independent variable. The relationship between the independent variables causes the problem of multicollinearity. And next question is, remedial measure for multicollinearity is A. Combine cross-sectional and time series data, B. Increase sample size, C. Omit high correlated variable, D. All of the above. Answer is D. All of the above. Combination of cross-sectional and time series data, increasing the sample size and omitting high correlated variable will help to solve the problem of multicollinearity. Next is factor analysis and PCA, that is principal component analysis, are used as remedy for A. Multicollinearity, B. Autocorrelation, C. Heteroscedasticity, D. All of the above. Answer is A. Multicollinearity. Factor analysis and PCA are used for multicollinearity. And next is dummy variable are used when A. Qualitative variable are involved in model, B. Quantitative variable are involved in model, C. Both A and B, D. None of the above. Answer is A. Qualitative variable are involved in model, then we use dummy variable. Qualitative variable are those which cannot be quantified. For example, hair color, color of eyes, color of leaves, etc. The next question is autocorrelation coefficient range A. -1 to +1, B. 0 to 1, C. -1 to +1, D. 0 to infinity. Answer is -1 to +1. As like correlation coefficient, the range of autocorrelation coefficient is also -1 to +1. The range of Durbin Watson D statistic A. 0 to 4, B. 0 to 1, C. 0 to 2, D. 1 to -1. Answer is A. 0 to 4. Durbin Watson D test is used for detecting autocorrelation, and the range of Durbin Watson D statistic is 0 to 4. If the successive value of error term changes sign frequently over a period, then it is A. Positive autocorrelation, B. Negative autocorrelation, C. Non-autocorrelation, D. All of the above. Answer is B. Negative autocorrelation. You can see here in the graph, the error term signs are changing. First it is negative, then positive, again negative, positive. If such type of trend is there in error term, then it is called as negative autocorrelation. If D is equal to 2, that is Durbin Watson D statistic is equal to 2, then A. Non-autocorrelation, B. Autocorrelation, C. Both A and B, D. None of the above. Answer is no autocorrelation. If the Durbin Watson D statistic value is 2, there is no autocorrelation. If it is equal to 0, there is positive autocorrelation, and if it is negative 4, it is negative autocorrelation. The range of D statistic is 0 to 4. Autocorrelation can be detected by A. Run test, B. Durbin Watson test, C. Graphical method, D. All of the above. Answer is all of the above. Run test, Durbin Watson test, and graphical method. These three are used to detect the autocorrelation problem. If the successive values of error term do not change sign frequently, then A. Positive autocorrelation, B. Negative autocorrelation, C. Non-autocorrelation, D. All of the above. Answer is A. Positive autocorrelation. You can see here in the graph, the sign of error terms is not changing frequently. If it is negative for first two values, then it becomes positive. Again it is positive for continuously for 5, and then again negative. If such type of pattern is there, then it is positive autocorrelation. Next is an error term with preceding property is called A. Autocorrelation, B. Heteroscedasticity, C. Multicollinearity, D. white noise. Answer is D, white noise. White noise is in engineering literature is termed as error term with a preceding property, which means that value of disturbance term in period t is equal to rho times its value in the previous period, that is t minus 1 plus a purely random error term. This is termed as white noise error term. If the disturbance term having constant variance for each value of xi, this condition is called A, non-autocorrelation, B, autocorrelation, C, heteroscedasticity, D, homoscedasticity. Answer is D, homoscedasticity. If the disturbance term, that is error term, is having constant variance, then it is termed as homoscedasticity. That is the one of the assumption of OLS. And if it is not followed, that is if error term is not having constant variance, then it is termed as heteroscedasticity. Heteroscedasticity can be detected by A, graphical method, B, Park test, C, Gleister test, D, all of the above. Answer is all of the above. Graphical method, Park test and Gleister test are used to detect the heteroscedasticity problem in the model. The two stages involved in detection of heteroscedasticity is A, Park test, B, graphical method, C, Gleister test, D, both A and B. Answer is A, Park test. In Park test, two stages are involved in detection of heteroscedasticity. What is the remedial measure for heteroscedasticity when sigma square is known? A, SLS, B, ILS, C, probability method, D, weighted least square method. Answer is D, weighted least square method is a remedial measure for heteroscedasticity when sigma square is known. Next, heteroscedasticity can be corrected with the help of A, OLS, B, GLS, C, ILS, D, both A and B. Answer is B, GLS. GLS is nothing but generalized least square method can be used to correct the heteroscedasticity. Goodness of fit is measured by A, coefficient of correlation, B, coefficient of regression, C, coefficient of determination, D, t-test. Answer is C, coefficient of determination, that is R square is used to measure the goodness of fit. In the regression analysis, the value of independent variable is A, fixed, B, variable, C, both fixed and variable, D, none of the above. Answer is B, variable. The values of independent variable are changed to know its effect on the dependent variable, that is Y. Exogenous variable in regression analysis is A, dependent variable, B, independent variable, C, both A and B, D, superfluous variable. Answer is B, independent variable. Exogenous variables are those variables whose values are not affected by any other variable. So that variable is nothing but our independent variable. Next is random variable is a variable that can take only positive values, B, only negative values, C, either positive or negative, D, neither positive nor negative. Answer is C, either positive or negative. Random variables can take both positive as well as negative values. That's all for today's session. If you have any doubt, you can ask me in comment section or message me on Telegram group Ecotalks. Don't forget to like, share and subscribe to my channel Ecotalks. Thank you.